Good day, everyone. This is General Mathematics, and I am your subject teacher, Mr. Jemacho E. Salandanan, LPT. Today, we are going to continue our discussion of General Mathematics Module Number 1, which is entitled Understanding Functions. So for today, we are going to proceed with our third lesson. Our third lesson is entitled Rational Functions, okay? But before that, let us have some sort of review. These are the operations on functions. So let f and g be the functions of the variable x. The sum of function f plus g of x is equal to f of x plus g of x. The difference of functions f minus g of x is equal to f of x minus g of x. F times g of x, or the product of function, we have f of x times g of x. Quotient of functions f divided by g of x is equal to f of x divided by g of x, provided that g of x is not equal to 0. Okay, we also have our composition of function. F of g of x is the same as f of g of x. So for today, we are going to discuss rational functions, rational equations, and rational inequalities. A rational function is a function of the form y is equal to f of x, which is equal to this, p of x over q of x, where the numerator p of x and the denominator q of x are both polynomial functions, and the denominator q of x is not equal to 0. So the domain of the rational function f is the set of real numbers except those values of x that will make the denominator 0. Why? Because if the denominator of a given rational function is equal to 0, the whole function is undefined. Okay? So this is again our rational function. Y is equal to p of x over q of x, or p of f of x is equal to p of x over q of x. If p of x over q of x is equated to 0, then p of x over q of x is equal to 0 is what we call rational equation. If this is equated to 0, then that is rational equation. Moreover, if the equation symbol here is replaced by the inequality symbol, such as less than or equal to, greater than or equal to, you have rational inequality because we are using inequality symbol. So again, if we have f of x is equal to p of x over q of x, that is rational function. If this is equated to 0, we have rational equation. If this, or if the equal symbol has been replaced by these inequality symbols, we have rational inequality. So let us have an example. F of x is equal to 2x plus 2 over 3x minus 8 is a rational function. As you can see, our p of x, or the numerator, and our q of x, 3x minus 8, are both polynomials and is named by a function. Okay, so this one is a rational function, whereas 2x plus 2 over 3x minus 8 is a rational equation because it is equated to 0. And lastly, 2x plus 2 over 3x minus 8 is greater than or equal to 0 is a rational inequality because we uses inequality symbols such as this one, greater than or equal to symbol. Now, let us proceed with the domain of the rational function. So, meaning to say, these are the permissible values of x of a given rational function. Okay? So, the domain of the rational function f is always the set of real numbers. The set of all real numbers except those values of x that will make the denominator equal to 0. Because if the denominator is equal to 0, the whole rational function would be undefined. So let us have an example. So f of x is equal to 5x minus 9 over x minus 6. How are we going to determine the domain of this rational function? Okay, so what we're going to do is to get our denominator, x minus 6, then we are going to equate it to 0 so that we will be able to determine what are the values of x that will make the denominator equal to 0. So we have here negative 6 will be transposed to the other side, though there is no actual transposition in mathematics, but we are doing it. So x minus 6 is equal to 0 would be x is equal to 0 plus 6. Okay? And x is equal to, what is 0 plus 6? That is equal to 6. Meaning to say, if our x would be 6, the denominator would be 0. If our x is 6, the denominator would be 0, making our rational function undefined. Okay? Suppose we have our values of x, which is, suppose our x is 6. We have here 5 times 6 minus 9 over 6 minus 6, which is equal to 5 times 6 is equal to 30 minus 9 is 21 over 6 minus 6, 0. So since the denominator is 0, our whole function or rational function is undefined. Okay, that's why the domain of the rational function would be set of all real numbers except 6. Okay, so again, our domain of the rational function is set of all real numbers except 6. We can also write that in this form. Set of all x such that x is not equal to 6. Okay? Let us have another one. Let us find the domain of the rational function f of x is equal to 5x minus 9 over 2x plus 6. So what we're going to do is to equate our denominator 2x plus 6 to 0. Then we are going to solve for x. We have 2x plus 6 is equal to 0. 6 will be transposed here, making 2x is equal to negative 6. To isolate x, we are going to divide both sides by 2. 2x divided by 2 is x. Negative 6 divided by 2 is equal to negative 3, meaning to say our x is equal to negative 3. If our x here is negative 3, our denominator would be 0, making our rational function undefined. So 2 times negative 3 is equal to negative 6 plus 6 is equal to 0. Therefore, the domain of our rational function is set of all real numbers except negative 3, or set of all x such that x is not equal to negative 3. Let us have another one. F of x is equal to 15x plus 23 over 12x minus 4. We are going to equate the denominator 12x minus 4 to 0. Okay? We don't care first here in our numerator. What we care more is our denominator. We're going to equate it to 0. Equate the denominator 12x minus 4 to 0, then solve for x. Okay? So 12x minus 4 is equal to 0, giving us 12x is equal to 4 upon transposing this or using addition property of equality. 12x is equal to 4. To isolate x, we're going to divide both sides by 12. 12x divided by 12 is equal to 1, or x. 4 divided by 12 is equal to 1/3. So therefore, our x is equal to 1/3. And again, our domain of this rational function is set of all real numbers except 1/3, or set of all x such that x is not equal to 1/3. Let us have another one. Suppose we have f of x is equal to 2x plus 5 over x squared plus 5x plus 6. Again, our first step is to equate the denominator x squared plus 5x plus 6 to 0. Then we are going to solve for x. So this x squared plus 5x plus 6 will be equated to 0, giving us x squared plus 5x plus 6 is equal to 0. As you can see, this trinomial is factorable. Okay, so we're going to factor this out. X squared plus 5x plus 6 is the same as x plus 2 times x plus 6. These factors is equal to 0. We're going to use the zero product property, or we're going to equate both factors to 0. We have x plus 2 is equal to 0 and x plus 3 is equal to 0. Upon solving for x, this will give us x is not equal to negative 2, x is equal to negative 3. The domain would be set of all real numbers except negative 2 and negative 3. We can write this also as set of all x such that x is not equal to negative 2, negative 3. if we substitute -2 here or -3, the denominator would be 0, making the rational function undefined. Okay? Now, let us have the applications of rational function in a real-life context. In an escape project for recyclable product in a barangay in Cuenca, recycling trash cans for separating and storage were provided to the captain of the barangay. The total cost, denoted by C, expressed in 1,000 pesos, of supplying beans to the P% of the population is given by this rational model. So C of P is equal to 150P over 1 minus P, where C stands for the total cost in 1,000 pesos and P is the percentage of the population. Okay, so the total cost of this project depends on the percentage of the population, okay, of the barangay. Find the cost of supplying trash cans to 25% of the population, 40%, 60% of the population. And also, according to the given model, would it be possible to supply trash cans to 100% of the residents? You're going to explain why. Using our model, C of P is equal to 150P over 1 minus P, where C stands for the total cost and P stands for the percentage of the population that will benefit or will be the beneficiaries of the trash bins. Okay, since we cannot operate percentage here, we're going to transform it into its decimal form. So 25% will be transformed as 0.25. C of 0.25 is equal to 150 times 0.25 over 1 minus 0.25. 150 times 0.25 is 37.5 over 1 minus 0.25 is 0.75. 37.5 divided by 0.75 gives us 50, or the total cost for 25% of the population would be 50,000 pesos. Now, if the percentage of the population who will benefit from the project is 40%, we have C of 0.40 is equal to 150 times 0.40 over 1 minus 0.40 is equal to 60 over 0.60. 60 divided by 0.60 is equal to 100. 100,000 pesos would be the total cost. Okay? And if the percentage of the population is 60, we have 0.60 here. C of 0.60 is equal to 150 times 0.60 over 1 minus 0.60. 150 times 0.60 is 90. 1 minus 0.60 is equal to 0.40. 90 divided by 0.40 is equal to 225, or the total cost, 225,000 pesos. In this particular model, would it be possible to supply trash cans to 100% of the residents? You're going to explain why. So, since we can't operate using percentage, we're going to transform it into its decimal form. The decimal form of 100% is 1. Okay, so we are going to compute for C of 1. C of 1 is equal to 150 times 1 over 1 minus 1, giving us 150 times 1 is 150, 1 minus 1 is 0. 150 divided by 0 is undefined. It is not possible since when P is 100%, the denominator will become 0 and C will become undefined. So the answer here is not possible. That is not possible. Now, let us proceed with solving rational equation. Okay? Solving rational equation, suppose we have 1 over 2x plus 5 is equal to 3 over 2x minus 1. We are going to solve for x. What are we going to do? We're going to multiply both sides by the LCM. The LCM of this rational function is 2x plus 5 times 2x minus 1. My shortcut here is I am cross-multiplying. Okay? I cross-multiply these two. So we have here 1 times 2x plus minus 1 and 3 times 2x plus 5. So cross multiply. Okay? 1 times 2x minus 1 is equal to 3 times 2x plus 5. Now, we are going to use distributive property of multiplication over addition. 1 times 2x is 2x. 1 times negative 1 is negative 1. 3 times 2x is 6x. 3 times 5 is equal to 15. Now, we are going to use the addition property of equality, meaning to say all with variable x will be included here, and those constant will be put in this side. Okay, so we have 6x will be transposed here, negative 1 will be transposed in this side. So 2x minus 6 is equal to 15 plus 1. Now, we are going to combine like terms. 2x minus 6 is equal to negative 4x. 15 plus 5 is equal to 16. Now, we're going to isolate x by dividing both sides by negative 4, giving us x is equal to negative 4. So, negative 4 divided by negative 4 is equal to 1, or negative 4x divided by negative 4 is equal to x. 16 divided by negative 4 is negative 4. So, meaning to say, the value of our x here in these rational equations is negative 4. Okay? Suppose we substitute negative 4 here. 1 over 2 times negative 4 plus 5 is equal to 3 over 2 times negative 4 minus 1. Let's see if this side is the same as this side. Okay? 2 times negative 4 is equal to negative 8. We have 1 over negative 8 plus 5 is equal to 3 over negative 8 minus 1. Upon simplifying, we come up with 1 over negative 3 is equal to 3 over negative 9. Now, let us express this in lowest term. So, 1 over negative 3 is the same as negative 1/3. Okay? That is equal to 3 over negative 9 is also negative 1/3. Okay? So, these two sides of the equations are the same, meaning to say, really, the value of x here is negative 4. Okay? Let us have another example. Now, let us solve this rational equation. 3x plus 2 over 2x minus 4 is equal to 2. We are going to solve for the value of x that will make this a true statement. So, our first step is to multiply both sides by the LCM 2x minus 4, or just use cross multiplication. Okay? So, just express 2 as 2 over 1. Okay? So, we have here, upon cross multiplying, 2 times 2x minus 4 is equal to 3x plus 2. Then, you're going to use the distributive property of multiplication over addition. 2 times 2x is equal to 4x. 2 times negative 4 is equal to negative 8 is equal to 3x plus 2. Then, addition property of equality, 3x will be transposed here. Negative 8 will be transposed on this side, giving us 4x minus 3x is equal to 2 plus 8. Now, combining like terms, 4x minus 3x is equal to x. 2 plus 8 is equal to 10. Okay? So, meaning to say the value of x is equal to 10 upon substituting 10 to this equation, giving us 3 times 10 plus 2 over 2 times 10 minus 4 is equal to 2. So, 3 times 10 is 30, 2 times 10 is 20, 30 plus 2 is equal to 32, 20 minus 4 is equal to 16, which is equal to 2. Now, dividing this, 32 divided by 16 is equal to 2, which is equal to 2. Okay? Both sides of the equation is equal. That's why x here is really 10. Let us have another one. Suppose we have 2 over 3x plus 3 over 4 is equal to 1 over x. Our first step is to multiply both sides by the LCM, 12x. Okay? So, 12x divided by 3x, giving us 12x divided by 3x is equal to 4. 4 times 2 is equal to 8. Okay? Next, for the next term, 12x divided by 4. 12x divided by 4 is equal to 3x. 3x times 3, giving us positive 9x. Okay? Next is for the last term, 12x divided by x is equal to 12. Okay, 12 times 1 is equal to 12. So we have now this new equation, 8 plus 9x is equal to 12. Okay, addition property of equality, positive 8 will be transposed to the other side. 8 will be transposed here, making it negative. So we have 9x is equal to 12 minus 8. Okay, combining like terms, 12 minus 8 is equal to 4. Isolate x by dividing both sides by 9, giving us x is equal to 4 over 9. Okay, so the value of x here is 4 over 9. Now, let us solve rational inequalities. Solving rational equality. A rational inequality is an inequality which involves one or more rational expression. Solving an inequality is much like solving equality. The additional steps below focus on how to illustrate the solution set of an inequality on a number line. Number one, these are the steps to follow in illustrating the solution set for a rational inequalities. Assume. We are going to assume the inequality as equality. How? By replacing the inequality symbols by the equal symbol. Then solve for x. You have now the first value of x, or our first critical values. Second step, determine any value which makes the denominator equal to 0. Thus, the expression is undefined. So, in this point, we are going to solve for x also. And these are our next critical values. So, as you can see in number 1, and in step 1 and in step 2, we are solving for x. And these x's are our critical values. Third, on a number line, mark appropriately the critical values obtained in steps 1 and 2, and those values will divide the number line into several intervals or regions. Okay, so let us proceed with our step number 4. For each interval, choose a test point and check if the point satisfies the given inequality. If a point satisfies the inequality, then the interval to where it belongs is part of the solution set of the inequality. Last, mark the number line appropriately to illustrate the entire solution set of the inequality. For us to better understand solving rational inequalities, let us have an example. Let us illustrate the solution set of 2 over x plus 5 is less than 4 over 11 in a real number line. Okay? The first step is solve the inequality as equality by replacing the inequality symbol by the equality symbol. So we are going to assume that they are equal. And let us apply what we have learned earlier. 2 over x plus 5 is equal to 4 over 11. Cross multiply, giving us 4 times x plus 5 is equal to 2 times 11. So 4 times x is equal to 4x. 4 times 5 is equal to 20 is equal to 2 times 11, 22. 20 will be transposed here, giving us 22 minus 20, which is equal to positive 2. So 4x is equal to 2. To isolate x, divide both sides by 4, giving us x is equal to 1 half, because 2 over 4 is equal to 1 half. X is equal to 1 half. This is our first critical value. Now, let us proceed with our step number 2. Step number 2 is we're going to find the values of x that will make the rational function or rational equation or rational inequality undefined. Okay, so here we are going to equate x plus 5 to 0. So x plus 5 is equal to 0. X is equal to negative 5. Upon transposing positive 5 to the other side, giving us 0 minus 5. 0 minus 5 is negative 5. Therefore, x is equal to negative 5 is our next critical value. Okay? So, for our next step, determine the critical values. The critical values are x is equal to 1/2 and x is equal to -5. We are going to mark this in a real number line. Okay? So we have here 1/2 and we have here 5, and these divide our number line into three regions. Region A, region B, region C, or this region, this one, and this one. Okay? Let us proceed with our step number 4. Again, the critical values are 1/2 and -5. Okay? These two critical values divide our number line into three regions. This region, this one, and this one. And these are the intervals for this region. For this one, we have -infinity. As you can see, there is an arrow symbol. -infinity up to -5. This region is from -5 going to +1/2. This region is from +1/2 going to +infinity. Okay? So these are the regions in our real number line. In these regions, we are going to, per region, we are going to choose a point in our number line that will serve as our test point. Suppose in this region, I choose -6. In this region, I choose -1. And in this region, I choose -5. You can choose any number or any point there in that particular regions. Okay? Now, these test points, -6, -1, -5, will be our supposed values of x that will be substituted here. So we have the first one, if x is equal to -6, we have 2 over -6 plus 5 is less than 4 over 11. So -6 plus 5 is -1. 2 divided by -1 is -2. 4 divided by 11 is 0.36. As you can see, -2 is less than 0.36. This one is a true statement, because -2 is really less than 0.36. Again, this one is a true statement. Therefore, we will have a check mark in this region, okay? From -infinity to -5. Let us proceed with our second region. Our test point is -1. If x is -1, we have 2 over -1 plus 5 is less than 4 over 11. -1 plus 5 is equal to +4. 2 divided by 4 is 0.5. 4 over 11 is 0.36. As you can see, 0.5 is not less than 0.36 because 0.5 is greater than 0.36, meaning to say this is not a true statement, making this region an X region. Okay? Let us proceed with our third region. Here, we chose 5 as our test point. If our x is equal to 5, we have 2 over 5 plus 5 is less than 4 over 11. 5 plus 5 is equal to 10. 2 divided by 10 is 0.2. 4 divided by 11 is 0.36. So this one is a true statement because really 0.2 is less than 0.36, making this a true statement. And this region is a check mark region. Okay? So, in these regions, -infinity, -5, -5, 1/2, 1/2 to +infinity. In these regions, only this region and this region have check marks. Okay? So, that means that the solution set for this rational inequality would be all values of x that are from here going there, or from 1/2 going to +infinity, and from here going there, from -5 going to -infinity. 1/2 and -5 are excluded. Okay? Based on our step number 4, the solution set to the inequality is marked in the number line. Okay? If you're going to turn your module, if you're going to get your module, please turn that on page 19. So these are the things that you're going to do in answering activity 4, test C. You're going to illustrate. That is how you're going to illustrate the solution set for an inequality, rational inequality. Okay? So now let us proceed with rational functions, solving rational function. Now let us try to solve rational function. A function f is a rational function if f of x is equal to g of x over h of x. As you can see, this is just a rewritten of p of x over q of x, but the thought are the same. G of x over h of x, where g of x, the numerator, and the h of x, the denominator, are both polynomial functions, and the denominator h of x is not equal to 0. The domain of the rational function f of x is the set of all real numbers except the zeros of the denominator h of x. In a rational function, the zeros, if any, of the numerator are said to be the x-intercept of its graph, while the zeros of the denominator, although not in the domain, also play a major role in its graph. Let us find the domain of the given rational function. Okay, so we have here three rational functions. What we're going to do is to determine its domain. So how are we going to determine the domain of this rational function? Equating the denominator to 0. Okay, so we have here x minus 2. The domain would be set of all real numbers except 2. Okay, this one, x squared minus 9, we are going to equate it to 0. So x squared minus 9 is equal to 0. X squared is equal to positive 9. So we're going to solve for x. So we're going to extract the square root of both sides. So the square root of x squared is x. The square root of 9 is positive and negative 3. It could be positive 3, it could be negative 3. So these are the values of x. Positive 3, negative 3. So therefore, the domain of this rational equation, rational function would be set of all real numbers except positive, negative 3. Okay, third, f of x is equal to x squared minus 4 over x minus 2. Again, equate x minus 2 to 0. Our domain would be set of all real numbers except 2. Let us have another one. Find the domain of the rational function. Number 1, f of x is equal to 1 over x plus 8. So we're going to equate x plus 8 to 0. The set of real numbers except negative 8 is our domain. Okay, so this one, just like our example earlier, x squared minus 4 is equal to 0. X squared is equal to positive 4. Extract the square root of both sides. We come up with x is equal to positive negative 2. So the domain would be set of all real numbers except positive negative 2. Whereas for this one, just like what we have learned earlier, x squared plus 4x plus 3, we're going to factor this out, giving us the values of x, negative 3 and negative 1. So the domain for this rational function, set of all real numbers, except negative 3 and negative 1. So, take a look at this rational function. F of x is equal to x squared minus 4 over x minus 2. We all know that the domain of this rational function is set of all real numbers except positive 2. Okay? But, if we express f of x as its reduced form, how are we going to get the reduced form? Factor the numerator, x squared minus 4 would be x minus 2 times x plus 2 over x minus 2. We're going to cancel this out, giving us or leaving us x plus 2. So x plus 2 is the reduced form of our f of x. Okay? This means that the graph of our f of x, which is equal to x squared minus 4 over x minus 2, and if g of x is equal to x plus 2, x plus 2, and the reduced form of f of x is also x plus 2, the graph are the same. Okay? This means that the graphs of f of x and g of x are the same except at x is equal to 2. Since the function f is undefined at x is equal to 2, thus the graph of f at 2y would be an open dot. So here is an open dot, 2y. To find the corresponding y value of the open dot, substitute 2 to the reduced form of the function. The reduced form is x plus 2. So 2 plus 2 is equal to 4. So the open dot would be at 2, 4. Okay? Now, questions. Are the graphs of the function f of x is equal to x squared minus 4 over x minus 2 and g of x is equal to x plus 2 the same? Are these two graphs the same? Are these two graphs the same? So the graphs of f of x and g of x are the same. Except, don't forget, except at x is equal to 2. Since the function f is undefined at 2, thus the graph of f at 2, 4 would be an open dot. Okay? So please remember this because this particular example is included in your prelims. Okay? So we are done with our discussion of rational function. I will no longer include graphs of rational function in our preliminary examination. I'm just going to upload a video lesson of that, so you will be able to know the rudiments of graphing a rational function. So, but I'm not going to include that in our preliminary examination. So our prelims would be module number 1, page 1 to page 17. Okay, so what you're going to do is to do activity number 4 only. Activity number 4 of our module number 1. Module number 1, page 19. So get your module, turn that on the last page 19, activity 4, number 1, letter A. Find the values that will make the function rational expression undefined. So hahanapin nyo lamang ang value ng ating x dito. Sa pangalawa naman, letter B, edi solve for the following rational equation. So solve nyo lang yung variables. So yung cross multiplication, solving for x, solving for A. Sa letter C naman, edi katulad iyan noong pinakita ko sa inyo kanina na solving rational inequalities. Dito sa letter D, in a look at the lesson sa page 14. 14. O yung tinuro ko kanina sa inyo ng cost sa mga trash bins. Okay? So, but this time, we are going to solve for 15%, 30%, and 80% of the population. Pwede maglagay ng decimal point? Pwede. Okay? So, you're going to do that sa papel, then maggagawa ako ng Google Form ng ano pala ng lalagyan ninyo or field na sasagutan nyo sa ating Google Classroom. Doon nyo ilalagay ang inyong sagot, okay? So good luck sa ating preliminary examination in General Mathematics, September 14, 2021, 1:15 p.m. to 2:15 p.m. Okay? Good luck. Thank you very much. If you still have question, you may approach me, you may chat me, you may message me, okay? Thank you.